Hey again, so let's get back into it. So I'm just going to make a copy of these first curves, and we're going to use our original curves as well this time. So what we're firstly going to do is we want to find the intersection of our scaled cut curve, splitting curve, with our original curves. I'll just pop I could have used that one, but I like to, keep it all related where I can. I just need these parameters that are, so we know that at these 4 points, this curve is going to be intersected by these 4 curves. Cool. So what I need to do is, when we, keep that there. So when we split these up, right, and we're splitting them, currently we're splitting them into four, so there's like one here, and then one here, one here, one here, one here, one here. So when we cut them out of 80mm plywood, they're currently flat edges. So like there's going to be, we could use glue along these seams, but that's going to be a really poor way to join them. So what we're going to do is at each of these joins, we're going to create some lap joints that essentially will remove half the material, 9mm in this instance, from this section, and the other one will kind of sit on top of it. And so we'll do that at each of these 4 positions. So we'll start to calculate that now, work that out now. So essentially we need to we're not just splitting these these surfaces here, 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 and here. We're going to split them twice. So to create, instead of 4 pieces, we're going to create 8 pieces kind of, and then do a few bits of computation around that to create the laps, or to create that lap joint. So let's define how big we want our lap section to be. So what we need to do is I want to tell Grasshopper to move up maybe 50mm, move down 50mm, and create this little lap section. So I think I want length parameter. Yep. Measure the length of the curve to and from a parameter. So I want to measure the length of, let me just remember what I want to measure the length of. I want to measure the length of this curve, to and from this parameter, I believe. Cool. And then I want to define the size of my lap to be, 25. I'm going to divide that by 2. So if I make that 50, it'll go 25 one way, 25 the other. And start to subtract that from our first parameter. So 20, our length parameter. Let me just bring it back up again. I believe it's this. Cool, length parameter here, 25 that way, 25 the other way. So we've got to do the addition for the other one. And so we're taking the same parameter, but we're adding the 50 on 2 to it, so 25. And now what I've done is, what we want to do is go evaluate length. Evaluate length, awesome. So I want to evaluate this curve at do I want it to be this length factor? Maybe. And we'll turn Boolean off. Cool. And let's see if we can get away with doing the other one. Length factor here. Oh, we've got a bit of an error that's popped up. And what does it say? Length factor cannot be smaller than the length of the curve. So what's going on here is that let's just go and endpoints, and I'll explain this one a bit quickly. Cool. So here's a curve. That's a start and end point. Here are the new points we've worked out. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And there's the end. What happens is, let's just say these points were close to the end of the curve, and then when we're evaluating the length, nearest to the point, nearest to those all the other points. When we've gone to add 50, it's gone over the end of the curve. Or when we subtracted, 25. When we subtracted 25, it's gone over the start. So what we've got to do is set up a condition that says if it gets to the end of the curve, switch the length back, switch the parameter back to the start of the curve. So I've done that in C#, and I'll paste that here. And so if I take this curve and I take these lengths and put that one there, and I copy this one and put these lengths in, this one, this should go away. And it hasn't worked. And I know why it's not working, because I was stupid and forgot that they're two different C# scripts. So let's try that again. I'll open the scripts up for you to have a look at soon. Where's our curve? In here and in here. Bang. Bang. So there we go. There's our curve. There's the two. There's our equal things. So what's going on under the hood? Well, we're taking the length of the curve. Sorry, the curve itself. Taking the parameter plus or minus 25, and then plugging it into a C# converter that's got curve as a list. There's a list of curves, and then lengths is a list as well, and type hint is double in the curve. The type hint is curve. Opening it up, creating some container lists, and then doing the alignment computations, what I called it. So if the lengths are less than 0, if it's negative, we're adding the curve length to it. And then in the other one, same inputs and outputs. If it's larger, if it's larger than the length of the curve, minus the sorry, if the length parameter goes over the length of the curve, minus the length from it. So anyway, that does the trick. And there we are. So let's continue on with the rest of it. And now we can create some perp frames. And we need to create some perp frames around here. Let's do one here. Use that to create one set of frames. Awesome. And then that'll do our other ones. And that looks quite good. And then we just need to merge these two together. We're very, very close to being done. And then we probably need to graft this. because I'm going to graft it and yeah, okay, and then trim it back down a bit. I'm just going to simplify that as well. Kind of want 8 in each. Yep, and that's what we've got. Nearly there. Curve closest point. And we want to find closest to our NURBS curves. I know it's a bit all over the place, but so a few efficiencies could be found. But I'm just trying to teach you the information as quickly as we can, and then let's start to draw some lines now between. I just need to simplify some other stuff. Simplify. Should be drawing a line between here and a line between here. Oh, that's maybe looking promising. And I have to remember where I drew the surfaces. Oh, wrong surfaces. But you should be able to get the point. There we go. So yeah, there's our cutting. There's our cut geometry being, well, our lap joints being created. Cool. We'll be making 3D in the next video.